So, the James Webb Space Telescope, JWST, spotted something wild. It looks like light beams are shooting out from a spot light years away that seems to be a happening place. This discovery has everyone wondering again about alien life. The telescope was aimed at Proxima Centauri b, the closest planet we know of outside our solar system, and it saw these weird, bright flashes. Could these be signals from a smart alien civilization? Keep an eye out for updates. For years, scientists and everyone else have been fascinated by the idea of life out there. Any hint of life in space gets people excited. But things got really interesting when JWST found some pretty convincing evidence suggesting life might be possible way out there. When it was checking out the universe, the telescope saw something crazy on a planet far away, light formations that looked like alien cities. This sparked the idea that there might be an alien city on that planet. This idea has made scientists super curious because it could mean we might be close to finding intelligent life that has civilizations we're just starting to understand. These city-like lights, seen from 4 light-years away, really surprised NASA scientists, making them wonder how long these signals have been around, just waiting for us to have the tools to see them. David Kipping, a scientist at Columbia University, said the planet with these lights is really complex. Unlike other planets that just soak up sunlight and shoot out infrared waves, this planet acts strange because of its special with its star, Proxima Centauri. This find points out how important JWST is. Its ability to see infrared light helped it spot the weird behavior of Proxima Centauri b, which is super important for understanding the planet's weather and air. Researchers plan to keep using the telescope to check out the planet's air, hoping to find out if it could support life. JWST is really good at seeing infrared light, so it can keep an eye on Proxima Centauri b, even on the dark side. Most telescopes can't see faint light in space, but JWST is amazing at picking up even the tiniest glows. That makes it perfect for checking if the lights on Proxima b's dark side are real. It can even spot lights made by aliens in space, as long as they're in a specific light range that's different from the light stars naturally make. Proxima Centauri b has a close with its star, which really affects things. Like other planets around stars, it gets a ton of energy from Proxima Centauri. As it goes around the star, it goes through cycles of light and dark, like Earth, with super hot days and much cooler nights. The temperature difference on Proxima Centauri b is huge, mostly because of what it's made of. If it has air, the difference between day and night temperatures would be extreme, scorching on one side and freezing on the other. This big temperature swing is a key thing to study, as it gives us clues about the planet's air. Since JWST can capture heat in the infrared range, it can check out the temperature patterns and the chemicals in the air. Interestingly, the telescope's path around Earth lines up with Proxima Centauri b's path around its star, letting scientists get good observations every 11.2 Earth days. If the planet has a lot of air, the next step is to study what's in it and see if it could support life. Finding gases like oxygen, methane, or water vapor would suggest that life might be possible. This means looking at how starlight passes through the planet's air, which is tricky but informative. Even though JWST is great at checking out exoplanet air, it was first made for other things. It's really good at spotting water vapor, carbon dioxide, and methane, but not as good at spotting free oxygen, which is a big sign of life. Still, it can detect other things, like ozone, which means there's a stable and protective atmosphere. As scientists dig into JWST's finds, the search for planets far away goes on. This work is slowly getting us closer to answering one of the biggest questions: are we alone? It's important to remember that JWST can only check out a few nearby exoplanets. For more detailed air checks, astronomers are getting ready to use telescopes on Earth, like the Extremely Large Telescope, ELT, which should be up and running in 2027. The ELT is designed to take a closer look at the air of planets far away, giving us better and more accurate info about whether they can support life. Scientists are excited for when we launch new telescopes like ELT. In the meantime, JWST is still super valuable for checking out planets far away. Even with its limits, it gives us key insights that could change how we see the universe. Astronomers have big plans for future tools. They're working on ways to block out starlight, making it easier to see planets around stars, kind of like shielding your eyes from the sun to see better. These telescopes aim to block out the bright starlight so we can see the faint light from planets and study their air. But this is really hard. Stars are super bright, often way brighter than the planets around them. That makes it hard to see the faint glow from planets, which has the info we need to study them. To fix this, scientists are coming up with new plans. One idea is a coronagraph, a tool inside telescopes that blocks starlight but lets the faint light from planets through. These devices change and control light waves, greatly cutting down on the glare from stars so astronomers can see light from planets. Another new way is the Star Shade, a huge, flower-shaped spacecraft that works with a telescope from thousands of kilometers away. It blocks starlight before it even reaches the telescope, letting only the faint light from planets be captured. This could be really helpful for seeing planets in the habitable zone, where there might be liquid water and conditions for life. These advanced ways need to be extremely precise. Lining up a star shade and telescope in space has to be accurate to within a millimeter. They also have to be small, use little power, and be tough enough to handle the harsh conditions of space. Even though there are problems, the potential reward is huge. If we can successfully study alien atmospheres, we might find biosignatures, chemical signs of life. Finding oxygen, methane, and water vapor in certain amounts could point to living things, making it one of the strongest signs of life beyond Earth. Scientists are also pushing things as far as they can go to get sharper, clearer pictures of exoplanets. Next-generation telescopes might have adaptive optic systems that fix image problems caused by Earth's air or the telescope's own movement. Combined with starlight suppression tech like coronagraphs and star shades, this would let us see things on planets like land, oceans, clouds, or even changes with the seasons. These high-definition views would be a huge step forward in how we check out and understand alien worlds, not just finding them, but actually studying their environments, weather, and potential life. As we keep going on this through space and our ability to see things grows, JWST and the tools that come after it become more important than ever. Its ability to see infrared light lets it spot faint planetary signs, check out air layers, and see signs of life that we might miss otherwise. Thanks to progress in technology and our growing knowledge about space, we're close to findings that could change how we see life in the universe. Finding human-made or city-like lights on Proxima Centauri b, our closest known exoplanet, could be the start of a whole new time in space. This ongoing mission isn't just about science, it also brings up deep questions about life. If we're not alone, what does that mean for us? How might meeting smart aliens change our future? The excitement about Proxima Centauri b shows how curious and eager we are to find meaning beyond our own world. New generations of telescopes in space and on Earth will keep pushing the limits of what we can see and understand. With better light filters, sharper images, and more advanced tools, we'll be able to check out planets far away in ways we never could before. Along with biosignatures, we might eventually spot technosignatures, like signs of advanced technology, such as signals or huge structures. With every new mission and every message from deep space, we get closer to answering one of the biggest questions ever asked: are we really alone in the universe? This big question, whether we're alone in space, has inspired tons of scientists, dreamers, and explorers. The recent news about Proxima Centauri b might be the thing that pushes us into a new time of. As we wait for more proof of the lights on the planet's dark side, researchers are putting more effort into understanding not just what these signals are, but also what conditions might allow life there. Science needs us to be careful, to do good, and to have evidence that others can check. While the lights we've seen might end up being from natural things like volcanoes, lightning, or weird reflections, the chance that they're from technology is still there and really. To find out more, scientists plan to make their tools more focused and have better resolution so they can separate and find signatures of the lights. These may help tell the difference between natural energy and energy from human-made things like power lines, messages, or factories. At the same time, space groups, schools, and companies are working together more. The race is on to make the next space stations, ones that can see more, are quicker, and can watch planets for a long time. One of the main goals of these missions will be to find alien life. This is looking for radio signals, lasers, or other messages from other living things. If we find life, it will change a lot about how we see ourselves in the world. While we wait, scientists are making models to know climates and conditions by using computer softwares. By making better models, we can better understand telescopes and see what signs we can find. Some people are trying to send out AI to space to see other planets, which is also a good mission to embark on.